Okay, moving on to 7-6. This is called Slope-Intercept Form. All right, on page 391, obviously section title is called Slope-Intercept Form. And so Slope-Intercept Form is this form of an equation that you can write. It's called y equals mx plus b. And in this equation, we know that m is the slope. In other words, it's the number that's right beside x multiplying by x. And b is called the y-intercept. Right? So here's what those two are. The slope, we've just got done doing the last three sections. Right? That's called rise over run. It's called delta y over delta x, which means change in y's over the change in x's. Or you could use the formula y2 minus y1 over x2 minus x1. All of those different things give you the slope. So if you found the slope of a line and you wanted to write it in slope-intercept form, you'd put it right there in for m. And then the other thing you do is when you look at that line, look at where the line crosses over the y-axis. That is called the y-intercept. So wherever it crosses over the y-axis, that is called the b. That's the number that you would put right there. All right, and we'll show that here in the next couple examples. Example 1 here says on page 391, state the slope and the y-intercept of the graph of y equals 3/5 x minus 7. So just going back to the last page there, right? Remember this y equals mx plus b, right? So the number beside x is m. Remember, that's the slope. So the slope in this problem is 3/5. And b is called the y-intercept. And so in this one, the y-intercept ends up being not positive 7, but negative 7 since there's a minus sign. All right, so those two terms end up being important. Y has to be all by itself on one side, and it has to equal whatever on the other side. And the number beside x is the slope, and the number that's all by itself, it's called a constant. The constant of negative 7 is the y-intercept. All right. And this is just extra. You don't have to do this on this problem, but let's just go ahead and graph it. So what happens here is this y-intercept ends up being your first point that you put down, right? So what I'm going to do is I'm going to start at the origin. I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7. It's right around there. Okay, so that is at negative 7. I know that that's a point on my graph, so I put that point down first. The slope, remember, should always be written as a fraction, so in this case it already is. And the rise is 3 and the run is 5. So what you do now is, remember, this is how steep the line is. So what we do is we start at that point we just made, and we rise 3, run 5, and put another point. So I'm going to go up 3, which would be there, and then over 5, which would be there. That's a nice point. And now that we have 2 points for a line, again, I would just graph the line. Notice I'm drawing it all the way through. But at least you have 2 points. Now if you wanted to make another point, you go up 3, over 5 again, you'd still be on the line. Up 3, over 5 again, you'd still be on the line. The other way is from here, you'd go down 3, left 5. You'd still be on the line. So in either case, that is how you would graph this without having to do an XY chart, without having to find other points. If it's already written in this form, this number is the slope, that's the y-intercept, and you can graph it really quickly. All right, example 2 says, state the slope and y-intercept of the graph of 5x plus y equals 3. So in this case, when you look at this one, it's not written in slope-intercept form. How do we get it in slope-intercept form is by getting y by itself. So in this case, to get y all by itself, this is what we end up doing. All right, so we've got our equal sign line here. We're going to subtract 5x on both sides. Now what that does, that cancels those out. Y drops down. On this side, it now says 3 minus 5x. Now, it's not written in slope-intercept form, technically, because it doesn't have mx plus b. So here's what we do. We use the commutative property and we flip this around. This is a positive 3, so that goes after. So now, just by a couple different things we've learned throughout the year, it's now written in slope-intercept form. So we can say that the slope is -5 and the y-intercept is, oops, that's supposed to be -5. And the y-intercept is positive 3. All right. So if you were to graph this one, let's do that real quick. Y-intercept of positive 3, so I would put that down as a point. The slope just helps me get the second point. So the slope, it's not written as a fraction here, so I would just put it over 1, -5 over 1. That means I rise -5, and I run 1. So from this point, going to go down 1, 2, 3, 4, 5, and run 1, and put another point. Now if I kept doing that in both directions, I would get points down 5 over 1 and up 5 left 1. Alright, so if you were graphing this line, which this one doesn't tell you to do that, but if you were graphing it, that's how you would graph it. Alright, example 4 says to graph y equals -1/2 x minus 4. So again, the number in front of x here, since it's y by itself, it's already written in slope-intercept form. So that makes it easy to tell what the slope is and what the y-intercept is. So let's go ahead and graph this now. Now notice the slope is already written in fraction form, which we want. But remember, the y-intercept is our first point. So I'm going to go down 4 and put a point. That's where this line will cross through the y-axis. Second part that I'm doing is using my rise of -1, since it's already written in fraction form, and a run of positive 2. So I'm going to go from that point, I'm going to go down 1, right 2, put another point. Now that's all I need. I can graph this line, but if you're wanting to just have a few extra points, you would go up 1, left 2, up 1, left 2, 1, left 2, up 1, left 2, and it should be in a straight line if you graphed it right. So it says to graph it, there is the line for the graph. Alright, let's move on. Alright, in example 4, this is a word problem. It says a t-shirt company charges a design fee of $24 for a pattern, then sells the shirts for $12 each. The total cost y can be represented by y equals 12x plus 24, where x is representing the number of t-shirts. Alright, so this one, as you can tell, 24 is the y-intercept. So that's the first thing I'm going to do. I'm going to try to count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's do this since that's so high. Let's go halfway down at 10. And in this case, we're going to have to scale it since I'm running out of room. You can tell in the book that they've scaled theirs. On the x-axis, they go every 1, 2, 3, but on the y-axis, they go up by 12 each time. So for this, what we'll do is we'll just make this up by 2 each time, each square. So right here is the 20, 22, 24. Alright, and it's not perfect, guys. You could go up by 3s, 5s, whatever. You probably want to use some numbers that obviously would go into 12 and 24 easily, though. So that's the first point. I'm done with the y-intercept. Second part is I use the slope. Alright, write it in fraction form if it's not. And then I got to go up 12 for the rise and run 1 for the bottom. So from this point, go 2, 4, 6, 8, 10, 12 over 1. Now go in the opposite direction, go down
2, 4, 6, 8, 12, left one. 2, 4, 6, 2, 4, 6, 8, 10, 12. I don't think I did that right. That should be there. There's the correction. Skip the number 10. But if I go down 12 over 1, down 12 over 1, or up 12 over 1, I still stay on that line. It's not going to be a perfect looking line, but that is the straight line. I've graphed it. Part A. Part B says describe what the y-intercept and slope represent. Well, the y-intercept represents the starting amount of money, right? So you haven't even bought any t-shirts. They're just going to charge you $24 to design it, basically. So that ends up being your y-intercept. If you remember this way back when, we called this a 0th term. 24 is the 0th term. That means no t-shirts. You haven't bought any t-shirts, but you still pay $24. And then the slope is your rate of change. So the rate of change ends up being $12 per shirt purchase. All right, that is the end of the examples. Best of luck.